Today we start from the next part of young Newton's law of motion, in which first, uh, what do you mean by force? So force is defined as uh, an external agency. You can say push or pull, due to which particle or object or body can change its state. What do you mean by state? State, not, it doesn't mean due to that you are from West Bengal to Uttar Pradesh. State means uh, the object from rest to become motion, or from motion to become rest. Means if you apply force, so motion become rest become motion, or if you apply in the opposite direction, then motion become rest. Okay. And also sometime, due to that force, the particle change its direction. Means suppose the particle is moving in this direction, due to force now it will be moving in different direction. So this one is called force. Now the second important term is from this chapter is inertia. What do you mean by inertia? Inertia is actually the opposition. Which type of opposition? If an object at rest, it will try to be at rest. If an object is at motion, it will try to be at motion. If you want to change its form, means from rest to motion or from motion to rest, you have to give some extra force. You have to give some extra force. That means which try to oppose it, and that's why you need that extra force to change its speed, or to change its direction of speed, or to change of state from rest to motion. So this tendency, this opposition tendency, is called the inertia. So inertia is actually resistance to change. Inertia is actually resistance to change. First, uh, given about inertia, the idea of inertia given by Galileo. Now, inertia is three types. One is called inertia of rest. When the object is at rest, it's called inertia of rest. Matlab, if the object is at rest, it's try to be in rest. If the object is in motion, it try to be in motion. So when the object is at rest, it try to be in rest. That is called the inertia of rest. Similarly, the second one is inertia of motion. If an object is at motion, it will try to be in the motion. So if you need to decrease that motion or increase that motion, or if you want to from motion to, if you want to become rest, you need extra force. So that tendency of opposition is called inertia of motion. And the third one is inertia of direction. What do you mean by inertia of direction? Suppose an object moving in a particular direction and you want to change that direction, then also you have to put some amount of force. So that is called the inertia of direction. Means if you not apply the force, then it will be try to be in the same direction. It's opposed to change that direction. So that's why you need some extra force. After this, the next important term is momentum. So which is represented by the symbol P, that is mass into velocity. That momentum is actually the effect of motion. The momentum is actually, you can say, the effect of motion, or you can say quantity of motion. Means the amount, how much motion is, it's depend on the momentum. How? Suppose a particle of very high mass, but if the velocity is very less, then the disaster is less. I can give you one example. Suppose you are standing in a road and a bike hit you, okay, but the bike is in a very high speed, so maybe because of that you can die. But suppose a car hit you, but the speed of the car is very less, so because of that maybe you are survived. So here the mass of the car is very large with respect to the mass of the bike, but the speed of the bike is very large, so it will affect you more effect created by the bike than the car, as the speed is very large with respect to the speed of the car. So that means the how you realize the force, means how you realize the effect of the force, it depend on mass as well as velocity. Are you getting my point, what I want to say?
Yes, sir.
So if the speed is high, so the effect is high. So on that basis you can imagine what happened if the light particle, they have some mass. Although the mass is not calculatable, they have mass, but that mass you can't calculate. But if that mass is calculative mass, the speed of the light is 3 into 10 to the power 8 meter per second, which is uh, you can say so many times larger than the speed of bullet. So many means 10 to the power 6, 10 to the power 7 times. मतलब 1 crore times larger than the speed of the bullet. So you can realize what happened if uh, light possesses some mass. So then if you remove your hand like this in front of the sunlight, your hand is vanish. You understand what I want to say? Or your hand is cut, like if you enter your hand in a blade, what happened? It just cut off now, means उसको क्या कहते हो, स्लाइस करना, स्लाइस करके निकाल देगा,
Yes, sir.
चॉपिंग करके निकल जाएगा. ठीक है. So that's why momentum is the mass into velocity. Next thing is that, so if you want to draw momentum versus velocity, they are directly proportional, and that momentum is the linear momentum. Here you can say mass is constant. If you want to draw momentum and mass, directly proportional if the velocity is constant, and if you want to draw mass and velocity, they are inversely proportional to each other if momentum is constant. Is it clear?
Yes, sir.
স্যার
Hmm.
স্যার একজনকে ওয়েটিং রুমে দেখাচ্ছে।
তো accept করো, করে দিচ্ছি আমি accept. হিমাংশু তো,
হ্যাঁ
কেউ
স্যার।
কেউ ওয়েটিং রুমে আসলে accept করবিস. Next is, after this, the next important term is how you relate momentum and kinetic energy. Very important. So the kinetic energy is, we know, half mv square. We can multiply it by mass, we can divide by mass. So what we have, m square v square by 2m, which is p square by 2m. So p square is 2m kinetic energy, p equals to root under 2m kinetic energy. This is the relation between momentum, mass and kinetic energy. Now from this relation we can again draw some graph like momentum and kinetic energy. They are directly, p is directly proportional to root under kinetic energy, and it look like this. Root y equals to root of x. The graph is look like this, where m is constant. Similarly, if we want to draw momentum and mass, and if anyone say kinetic energy is constant, so the graph is again look like this. And now if anyone asks you mass and kinetic energy graph, They are inversely proportional because this 2 equals to constant if P is constant. Is it clear?
Yes, sir.
If it is clear, then I want to give you a numerical. The question is that if the momentum increase by 50%, how the kinetic energy increase? How percentage kinetic energy increase? And for that, I give you 2 minutes.
Sir, mass constant. Energy gets doubled.
Anyone? Any other answer?
Sir,
Tell me the answer. Tell me the answer in percentage. Double means 100%.
yes, sir.
Yes. Tell me. Anyone? Any other answer?
স্যার 2.25 টাইমস বেশি হবে কিন্তু পার্সেন্টেজে কি 20
So it's very simple, very good, very well tried. And if you know the how much is the final, so the to find out the percentage is not very tough if you know unit and dimension properly. Like the percentage is how you find out the percentage. So first of all, if the P is the initial, if you 50% increase, that means P, the 50% increase, so P plus 50%, P by 2. So basically 3 by 2 P. So if the P 50% increase, so P becomes 3 by 2 P, matlab 1.5 P. Now we know the relation P equals to root under 2m kinetic energy and squaring both sides, P square 2m kinetic energy. Obviously, as they not mention about the mass, so that mass we suppose here constant. So we can write in that manner kinetic. So that means you can say kinetic energy final by kinetic energy initial. Mass is same, so you can cancel out. So P final by P initial square. So we have 1.5 P by P square, which is 2.25. So kinetic energy final is 2.25 kinetic energy initial. Up to this, Shagnik, you are doing very well. But after that, if you don't know how to find percentage, it's really what you can say, it's a shame. Kinetic energy final minus kinetic energy initial by kinetic energy initial means whenever you have to find out the percentage, the rule is that final minus initial by initial into 100, always you get the percentage. So from that you remember that, because that final minus initial by initial into 100, you see it in the fractional error, del f by original into 100. Even in class 8, 9, you are doing this in terms of profit and loss. So what happened? 2.25 kinetic energy initial minus kinetic energy initial by kinetic energy initial.
Sir, answer ki 125%.
Now to you know, I know 125%. So বুঝতে পারলি পার্সেন্টেজ কি করে বার করবি?
Yes, sir.
সব সময় মনে রাখবি, everyone always remember, whenever examiner asks you the percentage, so first find out the final value in terms of the initial value, and then final value minus initial value by initial value into 100. You always are getting the value of percentage. Is it okay, everyone?
Yes,
okay.
sir.
After that, yes, after that, the next important part is, after that, the next important part is, and it's my request to all of you, तुम लोगों को जो मैंने वो क्या कहते हैं फ्रिक्शन का शीट दिया है, प्लीज ट्राई टू सॉल्व, बिकॉज तुम लोग सॉल्व नहीं करोगे तो मैं उसको नहीं दिखाऊंगा। पहले तुम लोग सॉल्व करोगे फिर मैं उसको दिखाऊंगा, मतलब जो जो जगह पे प्रॉब्लम है। सो मेनी ब्यूटीफुल क्वेश्चन इज देयर, एटलीस्ट वंस, ट्राई वंस। अच्छा, नाउ न्यूटन्स लॉ. So Newton basically given three laws, three basic law in motion. They are very, very popular. Okay, the they are, the first one is first law, Newton's first law. So what do you mean by what he exactly given in first law, or what he want to say, that he if a object is at rest or if a object is at motion, means if you want to change its state means if the object is at rest, it become motion. If the object is at motion, it become rest. You can make it rest. So for that, you have to put some amount of force. So to change of state, you need force, or to change of direction, means suppose a particle is moving in this direction. Now by applying something, you are changing its direction. So you need to put some effort in terms of force. So what he say, every body continuous in its state of rest or uniform motion in a straight line. मतलब अगर रेस्ट में है तो रेस्ट में रहेगा, यूनिफॉर्म मोशन में है तो यूनिफॉर्म मोशन में रहेगा, unless it is compelled by some external force to change that state. चेंज ऑफ स्टेट मतलब यूनिफॉर्म मोशन में है और रेस्ट में है, इसको चेंज करना है, मतलब स्पीड को बढ़ाना है या स्पीड को घटाना है, और घटाते घटाते रेस्ट भी कर सकते हो. इसके लिए यू नीड अ एक्स्ट्रा फोर्स टू चेंज दैट स्टेट. तो सबसे पहले न्यूटन ने फोर्स के बारे में बोला बाय द फर्स्ट लॉ, और फर्स्ट लॉ इज वेरी मच रिलेटेड टू इनर्शिया, क्योंकि इनर्शिया में भी बोल रहा था है कि कोई ऑब्जेक्ट अगर रेस्ट में है तो रेस्ट में रहेगा, कोई ऑब्जेक्ट अगर मोशन में है तो मोशन में रहेगा. दैट प्रॉपर्टी, दैट ऑपोजिशन, मतलब जो रेस्ट में है वो मोशन में नहीं जाना चाहेगा, जो मोशन में है वो रेस्ट में नहीं आना चाहेगा. ये जो प्रॉपर्टी है इसको बोला जाता है इनर्शिया या रेजिस्टेंस ऑफ ऑपोजिशन, मतलब जो जिस जगह पे है उसमें रहना चाहता है. और न्यूटन ने इसमें ऐड किया कि स्टेट को चेंज करने के, मतलब स्टेट में रहना चाहता है, इस चाहने को चेंज करने के लिए तुम्हें एक्स्ट्रा इफोर्ट देना पड़ेगा इन टर्म्स ऑफ फोर्स. सो न्यूटन्स फर्स्ट लॉ इज रिलेटेड टू इनर्शिया. इज इट क्लियर एवरीवन?
Yes, sir. Yes, sir.
So that
Yes,
means
sir.
Newton's first law force के बारे में बताया. Now the Newton's second law. Newton's second law बोल रहा है the rate of change of linear momentum of a body is directly proportional to the applied force. मतलब मैं जो फोर्स अप्लाई करूंगा, this is directly proportional to rate of change of momentum. और जब मैं इसको इक्वलाइज करूंगा, एक कांस्टेंट आता है और देखा जाता है इस कांस्टेंट का वैल्यू 1 है, तो इसीलिए हम लोग इसको कभी कभी डायरेक्ट ही लिख देता है कि डेल पी बाई डेल टी लिमिट डेल टी टेंड्स टू 0 एंड एफ इज डी पी बाई डी टी. डायरेक्टली हम लोग लिख देता है. क्यों? बिकॉज ये मतलब चेंज इन मोमेंटम जितना बढ़ेगा या टाइम जितना घटेगा फोर्स उतना बढ़ेगा, पर कोई एक्स्ट्रा फैक्टर नहीं है. So we can use that constant, but when we calculate, we find the value of that constant is 1. So 1 को लिखना नहीं लिखना एक ही बात है, तो कोई लिखता नहीं है. So basically न्यूटन सेकेंड लॉ से तुम्हें फोर्स का मैग्नीट्यूड का आइडिया हुआ. So what is the basic difference between first law and second law? फर्स्ट लॉ से तुम्हें एक कुछ एक्सटर्नल एजेंसी लगेगा जिससे कारण तुम उसका स्टेट को चेंज कर सकते हो, और दूसरा में कितना चेंज हुआ, मतलब यूनिफॉर्म स्पीड का या यूनिफॉर्म वेलोसिटी कितना चेंज हुआ, या वेलोसिटी से तुम जब रेस्ट में लाए तो जितना चेंज हुआ कितना टाइम में हुआ, और इसके लिए कितना अमाउंट ऑफ फोर्स लगा, ये तुम कैलकुलेट कर सकते हो. तो बेसिकली न्यूटन सेकेंड लॉ से फोर्स का मैग्नीट्यूड के बारे में पता चला. इज इट क्लियर?
Yes, sir.
So that's why Newton's second law is very very important, क्योंकि इससे मुझे मैग्नीट्यूड के बारे में पता चलता है. अब इस न्यूटन सेकेंड लॉ का अगर
Sir.
मैं हाँ
স্যার এই c
বলো।
ইকুয়ালস কনস্ট্যান্টের ভ্যালু ইকুয়ালস টু 1 এটা কি এক্সপেরিমেন্টালি বার করা হয়েছে?
হ্যাঁ এটা এক্সপেরিমেন্টালি বার করতে পারিস মনে কর ইউ আর গিভিং র্যান্ডমলি সাম ভ্যালুস কি if the mass is that much velocity is initially that much final is that much within the time that much so what is the force so every time now again you change the velocity within a span of time and again you find out the force every time you see they are if you put the value of c every time you get the value of the c is 1 so you can from that you can conclude that the value of the constant is 1 okay so it's you can say experimentally you can find the value of c is constant 1 right
Yes sir.
now the very important is from Newton's second law derive the value of force which is very important so we know force is equal to according to Newton's second law force is equals to dp by dt so it is mass into velocity by time now a very two important differentiation now we apply here one differentiation we apply so the next second stage of differentiation if you find y equals to u into v u is one variable v is another variable and their multiplication form and if you want to differentiate them suppose we want to differentiate y with respect to time now u is also variable v is also variable how you differentiate that the rule is that keeping u constant differentiate v keeping v constant you can differentiate u is it okay is it okay देखो u को कांस्टेंट करके v को डिफरेंशिएट किया v को कांस्टेंट करके u को डिफरेंशिएट किया और दोनों के बीच में एक प्लस साइन दिया है इज इट ओके फॉर एवरीवन তোমার চাটা কিন্তু রাখা আছে ওখানে
Yes, sir.
next is y equals to u by v that is the multiplication form now it's a division form so dy by dt if you want to differentiate so how you differentiate see the velocity square v du by dt minus u dv by dt so this is called division form differentiation these two type of differentiation now we learn and if you want to find out how they are differentiate or in maths also you can find when you start differentiation the multiplication form of differentiation and division form of differentiation we just use that application to solve our question so is it okay for everyone is it okay for everyone hello अरे है ना किछु बोल ना बाबा
Yes, sir.
okay so 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 let's start to differentiate this on that basis so now if we want to differentiate this keeping mass constant we can differentiate time keeping velocity constant we can differentiate mass is it okay
Yes, sir.
but now during Newton's time means early 1600 century or at the end of almost 1500 century in that time Newton only concentrate up to this not this part because in that time we almost suppose ki mass is constant but later on we understand ki you can change the mass also with respect to time I give you one example later on so न्यूटन ने जो बोला था उस हिसाब से इसके बारे में कुछ नहीं बोला था न्यूटन ने. So according to Newton, क्या हुआ? Case 1, that is the actually given by Newton. If mass is constant, or if the mass is constant. If the mass is constant, we know the differentiation of constant is 0. So we can write dm by dt is 0. Is it okay?
Yes, sir.
So force is equals to mass into dv by dt plus 0. That is mass into acceleration. That is my force. So on that basis, from this rate of change of moment, we get the idea of force, or we get the idea of amount of force. Force is equals to mass into acceleration. But Newton Newton not give any information about that part. If the velocity is constant but the mass is changed. But now means in 2020-21, we can say also that is the case 2, and so many question asked from that part, because generally what we know from mechanics, if the velocity is constant, so no force apply. But here if you see, if the velocity is constant but your mass, rate of change of mass is variable, then also you can generate force. So case 2, if velocity is constant, so then the change of velocity with respect to time, we can say 0, because the differentiation of constant is 0. Is it clear? Is it clear?
Yes, sir.
So force is equals to, now this part is 0 plus v dm by dt. So we can say, means we can generate force by this process also. And now you have so many example like rocket propulsion. What happened in rocket propulsion? Your velocity of the rocket remain constant, but the amount of fuel burn per unit time you can calculate. That much amount of fuel burn per unit time, and because of that velocities remain constant. So you can find out the amount of force generated by the rocket. This is the first one. Second one is that, suppose in a hydel project you store some amount of water, and then you release that water from a height, so that water achieves some velocity. So, and there is a turbine, means a blade of the turbine is there. So when the water strikes with that blade of the turbine, the blade of the turbine starts to rotate. So here what happened, if we maintain the constant speed, and the amount of water strike per unit time, you can get the value, means they can give you the information. So then also velocity and dm by dt, you can generate force. Due to that force, the turbine is rotating, means the axle of the turbine is rotating, with which if you connect a coil in presence of magnetic field, so you can generate EMF. And we know it almost from class 10, I think you all know renewable sources of energy, idle energy.
Yes, sir.
Yes, sir.
So this one is also very, very important. Now I give you a question related to that part, because that force is equals to mass into acceleration. So many questions we already solved in Newton's first law. Then v equals to u plus at. Wherever you apply acceleration, if you put mass, you get the force. Now the question is that I would like to read the question. A block of metal weight 2 kg. A block of metal weight 2 kg. A block of metal weight 2 kg is resting on a frictionless plane. It is stuck by a jet releasing water at a rate of 1 kg per second. So you have a jet releasing water by which you are try to hit that metal, the dm by dt, it is given 1 kg per second, and at a speed of 5 meter per second. So the velocity of the water is 5 meter per second. You realize these things. कभी कभी तुम लोगों ने देखा है जैसे जहाँ पे गाड़ी धोता है, ठीक है ना, गाड़ी को वॉश करता है कार या बाइक, तो देखना वो लोग एक पंप चला देता है और एक पाइप से बहुत जोर जोर से पानी निकलता है। या कभी फायर ब्रिगेड का जो वो दमकल है उससे भी कभी कभी देखना काफी जोर से पानी निकलता है, और वो इतना जोर से होता है कि अगर कोई सामने में खड़ा है और उसके ऊपर फेंक दिया तो बेचारा मर सकता है या एकदम दूर में छिटक के जा सकता है। सलमान खान का भी बहुत सारा मूवीज में देखा होगा कि सलमान खान ने वो जो पाइप है उस पाइप का पानी फेंक दिया, गुंडा लोग सब गिर गया। देखा है सब मूवी सब वगैरह?
हाँ सर।
सलमान खान का बॉडीगार्ड में भी है ना। so whatever, আচ্ছা ঠিক আছে বুঝে গেছি আমি, চল বাংলা মায়ের অ্যাংলো সন্তান। so force is equals to velocity dm by dt, that is you can say mass into acceleration, and what you have to find out from the question, calculate the initial acceleration of the block. So here you have velocity 5 meter, dm by dt 1, mass of the block is 2, and acceleration, so you can easily capable to find out the acceleration of the block. Is it okay?
Yes,
Is it
sir.
okay?
Yes, sir.
After that, the next important topic, after that the next very important topic is impulse. The next very important topic is impulse. Impulse, which is represented by the symbol J, and yes, it is a vector quantity. So what do you mean by impulse? Impulse is, you can say, change in momentum. Impulse is, you can say, force into a very small amount of time or very small instant of time, and you can write it time 1 to time 2, means within that fraction of time. I can give you one example, like चलो suppose शोएब अख्तर ने बॉल कर रहा है, बॉल एकदम स्टंप की तरफ बॉल फेंका with the speed of 150 किलोमीटर पर आवर, mass of the ball is also there, suppose half kilo, तो स्टंप की तरफ आएगा, आ रहा है। अब सचिन तेंदुलकर ने क्या किया, उस बॉल को, बल्ला को ऐसे कर दिया, so बॉल आया, बल्ला में लगा, and then it is change its direction. So the ball is coming in this direction. After that, bat and the timings, tack. So the ball now change the direction. So initial momentum is in this direction and the final momentum is this direction. The change in momentum is the force and the timings, tack. अगर टाइमिंग्स काफी अच्छा रहा तो बॉल ओवर बाउंड्री, और टाइमिंग्स अगर कम हो, खराब रहा तो हाथ में कैच। सौरभ गांगुली को लास्ट के तरफ क्या होता था, सब बॉल में कैच आउट हो जाता था ऑफ साइड में, और वही पहले क्या होता था, सब ओवर बाउंड्री में जाता था। तो बेसिकली डिफरेंस क्या हो गया, एज के साथ साथ कभी कभी टाइमिंग्स में भी थोड़ा थोड़ा इफेक्ट पड़ता है। सो दैट फोर्स इनटू टाइम, अ वेरी स्मॉल इंटरवल ऑफ टाइम, the contact time between the ball and the bat, you can imagine it's a very small time, tack. So that small time into force is the change in momentum, and that change in momentum is called the impulse. So so in exam they can ask you impulse in terms of change in momentum, they can ask you impulse in terms of, they give you the force, and they can say you within that time find out the impulse. So if you want to write it graphically, so if this is the force and this is the time, so suppose in a very small interval of time, t1 and t2, you want to find out the impulse. So integration of f dt with the lower limit and upper limit, that is the definite integration. So you basically find out the area under the graph. Is it okay?
Yes, sir.
Ha.
Yes.
So in that way, you can find out the impulse. You can find out the impulse. So whenever you can imagine कि change in velocity wala question or force into time wala question, always write the whole formula like impulse, that is change in momentum, force into time. Then you can understand ki how you solve question related to that, because it will help you so much. Acha, one more example I can give you from where you can correlate them. According to Newton, force is del P by del T. So del P, that is F del T. So change in momentum, that is impulse. Is it okay? Or you can say in that way also, force is dp by dt. So dp is f dt. So taking integration dp, that is integration of f dt. So initial and final. So this is change in momentum, because if you write here p, that is p initial, p final, that is f dt, they can give you the value of f. So this is what? Final minus initial na? So that is change in momentum. It depends on the initial and final, and that is equals to force into dt. Is it okay? Is it okay? Is it okay? কেউ কিছু বলেই না, তোরা শুনতে পাচ্ছিস?
স্যার
হ্যাঁ,
স্যার চেঞ্জ ইন মোমেন্টামটা কি অনেক স্মল?
not necessary. Change in momentum তো অনেক বড় হতে পারে, but the time interval is very small. মানে স্মল বলতে কি, জাস্ট small time এ যেটা হচ্ছে, but it's not necessary they always give you the small. As they give you t1 and t2, they can give you for the large time interval also. But in general, my video is free. Are you sure? আমাকে দেখা যাচ্ছে?
Yes, sir.
Hello. আমি কি free? Okay. So now I give you some example numerical, then you understand how you solve question related to impulse. And in the next class, means Monday, I'm try to complete this chapter. So many parts remain, and then we if possible on Monday we start that collision, which is also very, very important. Okay. And then after complete the collision, maybe 1 or 2 class, within 2 class, then we move on to that circular motion next part. Okay, so our speed is very good. I think now we are in a very good rhythm. So my question is, zero, 5 second, 10 second, 15 second, and 20 second. Let it be 50 Newton, let it be 100 Newton. Suppose the mass of the body or object is given 2 kg. When the time is 0, initial velocity is given 10 meter per second. See, in general, if it is not given, that means the initial velocity is 0. But sometime examiner can also mention you at initial velocity is 10 meter per second, means when it starts, means the time is 0, your velocity is 10 meter per second. And now they ask you find velocity at 5 second and velocity at 15 second. Here the velocity means you have to find only the magnitude, because they are not mentioned anything about the direction, in which direction the particle is moving. So if they mention you ki particle is moving along the x-axis or y-axis, so that particular axis, because the force is acting in the same direction, so particles, so that direction is the velocity. So here you can say that is not velocity. They can ask you the speed also. Okay. So as we know, impulse, that is change in momentum, that is force into time. I already give you two Brahmastra. Number one, if by multiplying two physical quantity, if you get the third physical quantity, you have to find out the area. That is the first Brahmastra. Second Brahmastra is if you divide two physical quantity and you get the third physical quantity, then you have to find out the slope. So here it is clearly visible by multiplying two physical quantity, force into time. This is time in second, and this is the force. By multiplying two physical quantity, you get you get, or you are getting your desired value in, that means velocity at 5 seconds and velocity at 10 seconds. So basically we have to multiply. This means we have to find out the area. So if we start, so change in momentum, that means very simple, we can say momentum final, momentum initial, that is equals to, suppose we first find out the velocity at 5 seconds, as we know the velocity at 0 second. So our first range is 0 to 5 seconds. So we can easily find out that area, that is half base into height. So we have 250 by 2, that is 125, and here we can write mass velocity final minus velocity initial. Mass is given to velocity at 5 seconds, we have to find out, minus velocity at 0, that is 125. So velocity at 5 we don't know, but velocity at 0 second is 10 given. Mostly sometime they not giving anything, so that means in that time you can say velocity is 0, but here it is mentioned that the velocity is 10 meter per second. So you write 125 by 2, I guess 62.5 now. So V5 is 10 plus 62.5, that is 72.5 meter per second is the velocity at 5 seconds. Is it clear? Is
Yes,
it clear?
sir.
Yes,
Now,
sir.
if you want to find out the velocity at 15 seconds, because I'm just giving you two, you can find out the velocity at all point, means at 10, 15, 20 also. I just give you two different points. So it is
Yes.
your choice. You can start from here to here, the whole area, from this area to this area, the whole area, and then you can say change in velocity 15 and 0. This is one way. Another way is that, as you know the velocity at 5 seconds, so now you just find out this area, because this one now you know, and this one you have to find out. So you can find out only that area, and you know this one, and you can find out this one.
Yes, sir.
So this is one approach. Second approach is you can start from there to there, find out the total, and you start from 0. You realize you get the same value in both type, both the way. Okay, so let's start the second one. Again we write mass is 2, velocity final is 15. So now I'm not using this, I'm not direct, I'm not 5 into that change in velocity wala use kiya 5. Is it okay, or we have to write final momentum minus initial momentum?
No, sir.
We can write direct mass 2, velocity 15, velocity 0, velocity at 5 seconds, that is equals to area within that time. So this area, that is 5 into 50 plus area of the trapezium, which is some what is the formula of finding the area
Sir,
of the
half
trapezium?
into sum
Half
of
of the sum of the two sides. So 50 plus 100 into
height.
separation between this, that is 5. So what we have, 250 plus 75 into 5, that is 250 plus 375 na. So what you have 350 600 625 if I'm not wrong. Is it okay? So velocity at 15 second minus velocity at 5 seconds, 625 by 2, velocity at 15 second minus, that is 72.5, and 625 by 2 is how much? 312.5. So velocity at 15 second is 312.5 plus 72.5, that is 385 meter per second. Is it okay?
Yes, sir.
So in that way, my also class 10 up to class 10 from West Bengal board, then 11, 12 from the Bihar board. On that basis, I'm just saying. Okay. Acha, so the next question, which is very, very important. See the next question, which is very, very important. Same type of question, okay. But the difference is now, this time they give you the in terms of variable force, means everything is same. A particle of mass 2 kg, okay, initial velocity 10 meter per second when the time is 0, when the time is 0, and force apply, that is 3t square minus 4t plus 5 Newton. Try to understand, huh? Force is this much. The question is that find velocity at t equals to 10 seconds. Is it clear, everyone? Find velocity at t equals to 10 seconds. Everyone, is it okay?
Yes, sir.
So what happened here? See, the last one they give you graphically, but here they give you a variable force, and their demand is the same thing, means find out the final velocity. So what you can write, change in momentum, you can write directly, that is velocity final minus velocity initial, that is integration of f dt, and time 1 and time 2. I think you understand this one.
Yes, sir.
And here it is also given mass is 2, so we can write velocity at 10 second, we don't know. Velocity initial, if you want, you can write directly 10 because you know this value, which save your time also. Is it okay?
Yes, sir.
Yes,
That is
sir.
equals to 0 to 10 second time, 0 to 10, 0 and 10. Is it okay? Is it okay? Is it okay? And the force is given 3t square minus 4t plus 5 dt. So what we can write, 3t square dt integration
Yes,
0 to 10 minus 4 t dt 0 to 10 plus 5 dt 0 to 10. So what happened? 2 velocity at 10 second minus 10, that is equals to 3 t to the power cube by 3. I think we all know integration. These are the very simple integration. So these are not a very complex integration. So you can know very well 4 t square by 2. If you want, you can see that. If you are confusion in integration or differentiation, you can see my video in YouTube, that motion in one dimension, lecture 2 and lecture 3, I think. Okay. So from there, you can cancel this 3, you can cancel this 2. So now the upper limit is 10 to the power 3 minus 0 minus 2, 10 square minus, sorry, 0, and plus 5, 10 minus 0. So what you have, 1000 minus 200 plus 50. So you have 850. So velocity at 10 minus 10, 250 divided by 850 divided by 2, that is 425. So velocity at 10 is 425 plus 10, that is 435 meter per second. Is it okay, everyone? You understand? I think you understand.
Yes, sir.
সবাই বুঝেছিস?
Yes, sir.